I thought it was funny. I saw it funny. I'd be crying. I would be crying.
Wrong thing.
So when this morning.
I felt That's happening.
What a coincidence.
What?
Pink, pink.
It's not Wednesday though. Don't matter to me. On Wednesdays we were meat. I wore black last Wednesday. I wore. I don't think I was here. No, I was.
So the last bit of this is finding zeros with things that when you go into the problem are not factorable. So if I just put this up here on the board and I say, find all the zeros. To this point, what you would do is set it equal to 0, draw the wall, factor. But I don't know if you can tell this or not just from looking at it. If you're pretty good at grouping, you probably already know that this is not factorable. I shouldn't say that. It winds up that it is factorable. There's just no way that we would ever know how, myself included in that. So what's happening is we've got ourselves a polynomial here that has some zeros, but we, using the skills that we possess to this point, have no way of finding them. And so the crux of today, honestly, the next few days, is that I'm going to give you polynomials that when you first look at them, you cannot factor. That's not like a challenge, okay? It's just, it's not in the cards. And just to show you what I'm talking about, in case, you're still your brain's still on the weekend, maybe, I wouldn't write this part down, okay? I'm just going to erase all this. I just want to show you where I'm going with this. If I were to draw the wall down the center of this, and then I GCF out the left side, again, do not write this part down because I think later on you'll be confused by this. If I pull x squared out of the front, I get x minus 4. And then on the back, there's really nothing for me to pull out except a -1. And then I'm left with x minus 30. And grouping doesn't work when these two things don't match, right? So this is our first example of a polynomial that has 4 terms that isn't groupable, which begs the question, of course, then how do you expect me to do this? And that's where the title of the notes come from. If you look up above, you'll see that it says that you will be given 1, 0. And there's different means through which this can be accomplished. Sometimes it'll be a graph, but for now, for us today, there will be no graph given, but rather you'll be told something like this. And that information will come at you in a couple of different ways. Like it will be said different ways. So in the notes here today, I've got 4 examples and I'll have 2 examples of each so that you're comfortable with the lingo. So if x minus 2 is a factor, then there's a way that we can actually divide this polynomial down and expose the part of it that hopefully we can factor. And then tomorrow, we're actually going to do a lesson. It's a little sidetrack, but it's necessary. You'll remember this from Algebra 1, the quadratic formula. It's got the cute little song and all that. And we need to relearn, refresh ourselves on the quadratic formula because starting tomorrow, what we're doing today won't work all the way to the end. And the quadratic formula is our power move. It's like today, you'll see when we do this first step, something will happen that you go, okay, I can factor this. That will stop happening necessarily tomorrow. So starting tomorrow, we're going to need a more powerful weapon than just factoring. We're going to need the cover all beast mode quadratic formula, but just know that that's coming down the pike. But for today, something magic's going to happen. So the fact that x minus 2 is a factor is huge. It means that x equals 2 is a 0. And what that also means is that I can set up my purple numbers now and do some synthetic division. And that's what happens when we chip it down. So my purple numbers come from this polynomial right here, the dividend, right? So my purple numbers, remember, are 1, -4, -11, and +30. And we do our upside down division sign. And then we put the number +2. This is really important, okay? +2 goes out here. If x minus 2 is the factor, then x equals +2 is the solution, or the 0, correct? So what we're going to do now is we're going to chip down using synthetic division, and something will happen. So by the way, the fact that I told you that x minus 2 is a factor means necessarily that we are expecting the number 0 right here. So it might be a little bit presumptuous of us to put it in there, but it should happen. Unless I'm lying to you, or like unless someone's pranking you, if x equals 2 works, then that should happen. There should be a 0 when we get done with this process, and that's very significant. So we're a little rusty over the weekend. What's step 1 when we do our division? Yeah, take that 1 and pull it down, and then to come to just the multiply, add, multiply, add, multiply. It's like over and over again. So 2 times 1 is 2, -4 plus 2, -2, multiply those, -4, add those, -15, multiply those, -30. And as we expected, we got a 0. So that means that the problem was not a lie. It wasn't given to you in error or to prank you. X equals 2 is legit. So when we are finding zeros, we can already state with confidence that that one that I'm circling a lot up there will be one of the zeros that we list as a solution. We know this graph will interact with the x-axis at 2. Good so far? Now, remember from last week that these 3 numbers in this green box, they represent the quotient, correct? So what will the 1 represent? What is that? Good. 1x squared minus 2x. Good. Okay. Now what we're going to do is we're going to factor that. So the gist of this, which if you caught it right away, good job. If you didn't, you'll catch it in the next 3 examples. The first polynomial that I give you isn't conventionally factorable, but if we chip at it with the 1 freebie that we get, then the numbers that pop out are then factorable. And again, starting tomorrow, they will not be. Starting tomorrow, we'll have to use the quadratic formula on that little thing. But in this case, that's pretty light work for us, right? So if I go to factor this white polynomial down, it factors like this, correct? And what are the factors? X and X. Say again?
3.
Yeah, we need a 3 and a 5. And of course, the signs fundamentally are positive, negative. I doubt this far along into your algebra 2 that you're still struggling with factoring a quadratic trinomial. But if you are, boy, you better get a handle on it like now. Remember, the negative in the back means there's 1 of each. And then, of course, the numbers that we want are 5 and 3. And we want the negative to win. So we want the minus with the 5 and the plus with the 3. Okay. And then we're going to stick a little equals 0 right here and right here. Let's make this official. What zeros then do we get from these new factors, the new guys? What comes from this first one, the red one? Nice job. X equals -3. And what comes from this yellow one? Nice job. And then don't forget the OG guy that we got way earlier. Remember him from way up here? You got to bring him down now too. So there are the 3 zeros of the problem. So that's the gist for today. And we're going to practice this because as a teacher, you don't do one example. And if 3 people got it, you don't move on, right? We got to make sure all of you get it. So that's one example down. So we just found all 3 zeros of the polynomial, and it wasn't factorable from the get-go. That's what's pretty cool about it. It's me. All right, so our next one is going to be, today's assignment is pretty simple, just FYI. All right, so made a point, we're going to keep it basic today. So we have x cubed minus 2 x squared minus 29x minus 42. And this time, the language that I'm going to use is going to be a little bit different. Rather than saying such and such is a factor, I'm going to say this, that f of 7 equals 0. That means that if I put 7 into the function, I get 0. It also quite literally means that one of the zeros is very directly named x equals 7. When you're given the 0 as a factor, that's when you have to kind of make it equal 0 and do the opposite trick. But if I just straight give you f of whatever equals 0, then that whatever is your 0. Like no guesswork, no code breaking or anything like that. Good. So again, if you look at the original, you would agree it's, by the way, that's supposed to be a 42 at the end. I think I might have said it and not written it. So please make that change if you didn't. Did I say 42? I said it, I just didn't write it. My bad. So again, you look at the original problem and you would agree if you tried to do the grouping that you know how to do, that we know how to do, it isn't going to work, right? Pull out x squared from the front, you're going to have x minus 2, and then you can't pull anything out of the back. So again, we're left with like, I can't factor this, but thankfully someone swoops in and says, here's a freebie, 7's going to work. And so we're going to set up our purple numbers. They are 1, -2, -29, and -42. And what number am I going to put outside? Straight up 7, right? Remember, no sign changing on these ones, just the language is a little different. I'm giving you the 0, not the factor. That's a big deal. And then run through the algorithm and you know what to expect. If this statement right here, I'm going to put a yellow box around it. If that statement in the yellow box is not a lie, then you know that there's going to be a 0 here. So, I mean, if there's not a 0, then either the problem was written poorly by your math teacher or you made a mistake in the synthetic division process. So let's begin. Drop the 1, multiply 7, add 5, multiply 35, add 6, multiply 42, and there's your 0. Which necessarily now means that these 3 numbers in this green thing are the coefficients now of a second degree. We chipped a third degree down 1 degree to a second degree. So those 3 white numbers now represent 1x squared plus 5x plus 6. And we know now that we want that to equal 0. Pretty rinky-dink factoring from this point, right? I would think you'd be pretty hard-pressed to say, I'm stuck here. These factors pop right out. What are the numbers we're looking for? You don't want 6 and 1. 6 and 1 would be rad if the 5 in the middle was a negative, because then you could get the balance that you want. But you want 3 and 2, because everything's positive and they got to add to make 5. So we want a +3 and a +2. Therefore, the zeros are x equals -3, x equals -2, and then the OG guy, x equals 7. Would guess after the first example, about 3 of you were like, I get it. After that one, it's probably more like 7 or 8 of you. Let's do a couple more just to make sure it's all 13 of you or 15 of you. And again, just so you can plan ahead, I know I said this, but maybe you're more ready to hear this now. The change coming is that these numbers in the green oval aren't going to play nice starting tomorrow. They will sometimes, happenstance. I mean, but when they don't, then we need to arm ourselves with the ability to, you don't want to just put your pencil down and say, well, now I'm screwed, right? That's not how this works. So today, factorable, tomorrow, quadratic formula, and then the rest of the week, we're going to work with things that don't play quite as sweet. So next one, we have a polynomial. F of x equals x cubed minus 5x squared minus 8x plus 12. And the language this time, I'm going to alternate. So I'm going to go back to just telling you that x plus 2 is a factor. I'm giving you a 0, right? I'm just not giving it to you quite as directly as I did in the second example. So we do have to crack a little bit of code. What is the 0 then that I'm giving you? X equals -2, right? Remember, the 0 is the number that will make the divisor. If someone tells you that something's a divisor, then you need to make that divisor equal 0. That factor equaling 0 is what enables us to call it a factor. So once again, third verse, same as the first, we're going to set up our purple numbers: 1, -5, -8, +12. Upside down, divide that little bad boy and stick the 0, -2 out here. And we're off. And what are we expecting?
0.
Yeah, and if there's not a 0, again, it's either a poorly written problem, someone trying to prank you, or some ghetto math somewhere. You know, forgetting signs, 8th grade garbage, 3 times 4 is 7, stuff like that. So, all right, so we got the setup ready to go. Algorithm, repetitive, drop the 1, multiply, add, multiply, add, multiply, add. And there you go. And as advertised, we got the 0. What will our quadratic be that we're going to try to factor? It comes from this green oval right here. What do we get? 1x squared. Thank you. Yep. Good. And then to make it official, let's slap an equal 0 on the tail end of that. Yeah, let's get to factoring. Pretty rinky-dink factoring, I think you would agree. I need my x's. What are my signs going to be? Both negatives for sure. Good fundamentals. They multiply to make a positive, but add to make a negative. It's the only way for that to happen. And what numbers are we looking for? 1 and 6. And therefore, we're going to now list our zeros. And the zeros are x equals 1, x equals, and the OG, x equals -2. Yep. I'm guessing that's probably to the point where I can say all of you are feeling good. Let's put a bow on it. Let's do one more and make it official. And then the rest of the hour, you can just work on this. Okay. So this is your introduction to finding zeros when the first step isn't factoring. And then I say throughout the next week or so, it'll get, there comes a point later this week where I stop giving you zeros at all. And that's when it gets a little interesting. We have to use something called the rational root theorem to decide what zeros might work. There's going to be no freebies beyond a certain point. But we'll cross that bridge when we get there. So here's the last one. Last function, and these, I say these are all pretty repetitive. There's not any leading coefficients or anything like that. These are all cut from very identical chunks of cloth. So x cubed plus 3x squared minus 22x minus 24. And again, if we tried to factor it, we'd get butt right up against a wall. Ain't happening, huh? So this time the language, I'll change it back. We're going to say that f of -1 equals 0. What does that mean? That means that x quite literally and directly has to equal -1. That's the freebie that someone is giving you. They're saying the graph touches, crosses, bounces, whatever, does something interesting at x equals -1. So there's our freebie. So we're going to set up our purple numbers: 1, 3, -22, -24. Upside down division, that little mambo jambo. And what number goes outside? And so repeats the process. So this is how we get in and chip away at the stone when factoring initially is not an option. Are we factoring? Yes. It's just not the kind of factoring that we're used to. Kind of factoring in a very creative way. So we're going to drop the 1. We're expecting, of course, the 0. If not, something has gone wrong. Drop the 1 and we go. -1, 2, -2, -24, multiply, 24, 0, boom, done. So what are the coefficients of our quadratic? Yeah, you got a little ahead of me there. So what is the quadratic that I need to write?
X squared plus 2x minus 24.
Good. And then, of course, please put your equal zeros. That's something I don't want to have to ding you for, but it is a thing, right? And I didn't do a very good job on the first one. I delayed a little bit and went back. I should have done it at the time, but, you know, make sure your equal 0 is present until it doesn't need to be. So that's the equation now that we're trying to solve, and we solve it, of course, by just simple factoring. And like Mari said, we know we're looking for a 6 and a 4 of some type. We know that there's one with a plus and one with a minus. Who gets the plus? The 6 for sure. We want the stronger product to win when we add them together. So we have a plus 6x minus 4x, perfecto. So our zeros are x equals, and the freebie. And that is what you're doing today. You will be given 1 day for this. Tomorrow we move on. So this is not a multiple day. This should be a pain-free, pleasant assignment. Goes without saying, you'll be doing this on, paper. It is Delta Math, but that doesn't mean that I should see you with just a Chromebook, right? These are paper problems, and then you type in your answers. Got it? All right.